Problem 11. A closed box with a square base is to be wrapped with a square sheet of wrapping paper. The box is centered on the wrapping paper with the vertices on the base line on the midlines of the square sheet of paper, as shown in the figure on the left. The four corners of the wrapping paper are to be folded over the sides and brought to meet at the center of the top of the box, point A in the figure on the right. The box has base length W and height H. What is the area of the sheet of wrapping paper? So this question requires a bit of mental thinking of how it will look like. If you were to imagine wrapping the sheet of paper around, then you can imagine that if I were to do so, then where would the height be? Well, the height would be right here, right? Because think about it, you're wrapping this part over the paper, and so this side length must be H, and likewise everything else must be H with it. So with this out the way, what can we say? Well, we know that they're on the midlines, and we know they're perpendicular. And since by healthy suspicion we can say that they're 45, 45, 90 triangles. So what can we say about them? Well, let's first connect this line right here. If that's W, and that's W as well. And this would be W as well. But what is this side length? Well, that's side length, right? Let's call that X. If this side length were to be X, then this is also X. So that means if I were to connect it for every single rectangle, as you can see here, we can say that this is X, that's X, that's X, that's X, that's X, that's X. So then what is X? Well, X squared, 2X squared is equal to W squared. So that means X squared is equal to W squared over 2. And we can say that X is equal to the square root of W squared over 2, which is W over root 2. With that out of the way, what can we say about, if I do it in red, what is this side length? Well, that's Y, that's Y, that's Y, that's Y, that's Y, that's Y, and that's Y, that's Y. Healthy suspicion leads us to suggest that they're 45, 45, 90 triangles, which means that if that's Y, then the height is also Y. That means Y squared, 2Y squared is equal to H squared. That means Y is equal to H over root 2. So we have Y is equal to H over root 2, X is equal to W over root 2. We can solve for the entire area now. What is the one side length of the larger square? Well, if I scroll down a bit, right here, the one side length is 2x plus 2y, which is 2 times if x is equal to w over root 2 plus h over root 2, which means this is equal to 2 times root 2 in the denominator and w plus h in the numerator. So the area of the entire, well, what are we trying to find here? We are trying to find the box. What is the area of the sheet of wrapping paper? Well, the area will just be simply this quantity squared, right? So that means this would be 2w plus h over 2 root 2 squared, which is 4 times w plus h over root 2 squared. So that's equal to 4 times, that's 2, and we have w squared plus 2wh plus h squared. That means this is equal to 2w squared plus 4wh plus 2h squared. Now, what is our answer? Well, we don't have it in this form, but we have it in the factored form of 2 times w plus h squared. Why? Because w plus h squared is w squared plus 2wh plus h squared, which matches with this form right here. Therefore, your final answer would be answer choice A.